Hello, Python programmers. Let's talk about plotting, not plotting against each other, but plotting data using an open source library. Matplotlib? Matplotlib? Don't know. I usually say matplotlib, but I've heard it pronounced different ways. Open source means that you can download the programming for this library and look at it and make changes to it. Most things in Python are open source. It's the ethos, the culture of Python is that things should be available and free. We are not concerned about the particulars of what's going on behind the scenes in this library. We are simply concerned about how to use this library. Just as an aside, a quick tangent, if you settle on a library in a professional environment, make sure that you understand the ramifications of using that library relative to distribution. Make sure that you have the license, the legal right to distribute whatever you need to distribute. If you write the world's greatest Python app, then find out that a library you used has a royalty associated with it, you might be very upset about that. Always be aware that just because you can download something and install it doesn't mean that it's free to distribute if you're going to use it to make a profit. There are quite a few licenses out there in the open source world, and some of them may put a limitation on what you can do. We're not concerned about that here as much because we are just simply doing things for academic purposes and we have safe harbor in the world of academia to do some things that you might not be able to do if you work for a major corporation. Just always have that in the back of your mind. If you go to the Matplotlib website, you can probably find the license agreement, and you may have to run that by your general counsel. Again, not something we're concerned about with here, just thought I'd toss that in. We need some data for our simple examples. We're going to use a NumPy array and the arange function. I have an extra R in there. And that function will just generate some data for us. Easy enough to do. Take a look at that URL. You can see all the options that are available to you if you ever need to cobble up some data. Our first example looks like this. I am going to start from a brand new notebook. There he is. And I will start by putting into a cell at the top my import statements. I think that's an efficient way to work because I don't have to run that cell more than once. If I'm running the code cell by cell, I can run that cell at the outset of my work and then not have to do it again. Not going to slow me down very much. That's not a big ask for the computer to import those two libraries, but it's just a good habit, I think. And then I have three simple lines of code on slide 4. We're generating a range of data starting at 0, stopping before we get to 100, incrementing by 10. To build confidence in my work, I put a print statement in there just to see what I got when I called that arange function. And then I called plot in the most simplest way possible. I passed it that array of data, and it generated a plot. How about that? And it didn't because I didn't run the import cell as I was just harping about how neat that was. I didn't even do it. All right, run the import cell. Run my example code again. There we go. The printout of the data you can see is from 0 to 90. It stopped before it got to 100. It is not an inclusive upper bound. Incremented by 10, I have 0, 10, 20 on up to 90. And when I call plot against that range, the plot function in matplotlib is more than happy to make up the x values and then use my y values. If you've got a situation where you know what your y values are and your x values are just indexes starting at 0, then there's the world's simplest plot. Slide 5, let's get a little more complex. I will provide x data and y data. So what I did here was just cobble up two ranges using the arange function, starting from 0 going up to 50 by 5s for the x data, starting from 0 going to 100 by 10s for the y data. Print those out. Don't have to do that, just makes me happy. And then I call the plot function with two arguments. The first argument is the x data, the second argument is the y data. Let's take that back to our notebook. The first plot is a simple line plot. The second plot is going to print, instead of a line, it's going to print red circles. So I added a third argument to the plot function. I've got x data, comma y data, comma RO in quotes. And that's going to print on top of or overlaying the previous plot, which is going to give me a line with dots on it. Again, pretty easy to do. I can pretty easily set up a set of plots, and within 5 lines of code perhaps, including the code spent cobbling up the data, I can have a very quick and easy plot. Here's a challenge for you. I'll provide the solution for you, but take a minute and see if you can plot this data. I've got two disjoint ranges, and the numbers also go negative. So you may have to think about how to cobble up that data and how to get it on to the plot. So please pause the tape and see if you can get that to work. How did you do? Did you find a trick to let you get two plots onto the same chart? Or did you create a data set that looked like that one? I'll show you how I did it. I created two separate data sets, and then I used the append function of NumPy to create a third data set, combining the two, and then I plotted that. So that's one way to do it. I can run my little cell, and I can examine the data because I put my wonderful print statement in there, and you can see that the data goes from 0 to 9, and then all of a sudden drops down to -10, and then counts back to -1. When you plot that, the plot function wants that to be continuous, so it just drops down from 9 to -10 and then continues on its way. So it made sense to me to create one data set by appending two existing data sets. but it may have made sense to you to do it another way. Slide 7, introducing the concept of a subplot. Sometimes we want more than one plot and we want to manipulate them as a group. We can create a thing called a figure by calling plt.figure. So we call the figure method the figure function in the matplotlib library. And then we add subplots to that figure. In my example, I want 2 rows and 2 columns. So calling add subplot requires me to give the row and column number and the index number of what I'm adding to that figure. And then I cobble up some random data using another NumPy function. Finally, then I plot that random data. Let's take that over to our notebook. And you know what? We can't. We can't copy that code because it's a screen snip and not source code. But I can provide that for you. I'm going to add another slide. And I'm just going to paste in and rearrange a little bit to make it a little prettier. That's better. That's the copy of the slideshow that you will have. My apologies for that. Let's grab that code off the slide, take it back to our notebook. Pastes in beautifully. Even the quotes work that time, huh? So we are creating a figure. The figure is returned to us by the figure function, and I store that in a variable called fig. We could put a print statement after that. We love our print statements, don't we? Just to see what kind of data type that is. What data type is fig? And I'll talk about why that's important in a second. The next thing we do is add 3 subplots. I'm looking for my 2x2 configuration, 2 rows, 2 columns of subplots inside the figure. And I'm getting an index number which allows me to refer to the individual subplots by name. So now I have a way to add something to that subplot or add a plot to that subplot. And then finally, I couldn't stand it anymore, so I'm going to plot something. I can use plt.plot, which just tells matplotlib to whatever the last subplot I created, put the plot there. If I want to be specific and add to a particular subplot, I can use that variable that was given back to me when I called add subplot. So I have 2 ways of addressing the figure by subplot. I can address by the last one I referenced, or I can address by name. In this case, SP1, SP2, SP3. Let's see how this looks. Okay. I have 3 subplots inside my figure, and they look really neat and amazing. The first one, which I call SP1, just has a simple line plot in it. And instead of creating some data beforehand, I simply called the arange function, and then whatever arange gave back to me, which I know is that data set, I pass that directly into plot. And I'm asking for a range from 0.5 to 100 by increments of 0.1. and then the plot function comes up with the x-axis. You can see it's labeled 0, 250, 500, 750, 1000. The y-axis is the data I provided as the result of that arange call. And it's so convenient because the plot function made so many assumptions for me, and they're reasonable assumptions and they're often helpful. It decided to limit the number of ticks on each axis because they just got too busy. And it did a really nice job for me. The one above that is a different kind of plot. In this case, I'm asking for random data, but I'm asking it to take that random data and compute a running cumulative sum of that data, just to get something that's not linear. And then I'm asking it to plot using that k minus minus notation. And you can see how that ends up with the nice dashed line there. Now SP2 is empty. I plotted into the first subplot, I plotted into the third subplot, but I didn't specify anything in SP2. So let's see if we can just be a little bit devious. And SP2 dot plot. What's the worst we can do? What if we just try to cause some grief here? Let's ask for just probably what's going to be too much data. I'm going to copy what I did numerically from the third plot, but I'm going to drastically increase that number. Let's make it 50,000. You can put that underscore in there. Sometimes that helps the number to be more readable. I'm asking for a lot of points now in that tiny little space. I'm just curious. Okay. It handled it pretty well. It realized that there's an upper bound, and it realized that the x-axis only goes up to 50,000, and it just blurred a lot of the dots together. So we got a reasonable looking starting point from which we could enhance our plot a little bit. But you can see that the plot function is very, very flexible and very capable of dealing with different data sets. And it didn't take that long either. So it was able to evaluate 50,000 data points and compute an upper and lower bound and an x and a y range, and then plot those.